We have the 2.5b video. This is the second part, 2.5, where I want to talk about solving for a variable. And I want to try and highlight some misconceptions that we have had. So let's just fill out the first little bit and take a look at some of these examples, and hopefully we can clear the mud. Terms are separated by addition and subtraction. Well, I cannot write today. Terms are separated by addition and subtraction. Easy enough. When solving for a variable, we treat other variables like numbers. We treat other variables like numbers. If there's more than one term with the variable we are solving for, then we need to isolate, factor, and divide. Just one E. And obviously we'll see that in the third problem. Here is the important bit, factoring. We'll talk about that here more in a minute. Okay, so this asks us to solve for f. Fair enough. Usually whenever I have a number in front of a binomial, I want to distribute, but since I only have one term on the other side, I'm going to eliminate that by multiplying both sides by 9/5, the multiplicative inverse. This 5 cancels with that 5. This 9 cancels with that 9. I'm going to do to one side, I got to do to the other. So to clean this step up, I have 9/5 times c equals, and now I can drop my parentheses, f minus 32. Again, solving for f, all I need now to do is add 32 to both sides. So now I see I have 9/5 c plus 32 equals f. Now for this problem I want to solve for y, then I'm going to find the value of y for each value of x. So first let's work on solving for y. Here I have 3x minus 5y equals 9. And the first thing I want to do is I want to get rid of this 3x, and I can do that by subtracting it. Again, I'm treating it just like I would any other number, but I'm only going to combine my like terms. So here I'm left with negative 5y equals minus 3x plus 9, because I started off with a positive 9. Here's my positive 9. Now I want to divide by negative 5. And divide by negative 5. And I can see now that y equals negative 3x plus 9 divided by negative 5. And for our purposes here, I can stop. But now I need to solve for each value of x. My first value is negative 1. So I want to plug a negative 1 in here and see what we get. So I get y equals negative 3 times negative 1 plus 9 divided by negative 5. And I can simplify that. Negative 3 times negative 1 is a positive 3. So I have 3 plus 9 divided by negative 5, which leaves me with 12 over negative 5. And we don't want the negative in the denominator there, so we're going to say negative 12 fifths. Okay, not too bad. Now I want to plug, going back to this, I want to plug 0 in. Well, 0 times anything is 0, so I'll say when x equals 0, y equals 9 over negative 5, because I already know this is going to 0. And to simplify, we'd say negative 9/5. Okay. Well, now I want to do a positive one. So for x equals 1. I'm going to plug that in. And again, replacing my variable with parentheses and then plugging in my numbers. So I have negative 3 times that 1 plus 9 divided by negative 5. And this gives me 6 over negative 5, which simplifies to negative 6 over 5. Not too terrible. Now this is where I wanted you to remember that line we said I wanted to isolate, factor, and divide. Well, let's see what that looks like. So here I have Rx plus Sx over t equals 1. And I want to isolate the terms with x and them by themselves first. So to clear the denominator, I'm going to multiply both sides by t. And when I do that, that guy clears with the denominator, and I'm left with Rx plus Sx equals t. Now now I've isolated, now I want to factor this x out of both of them. So this is the undoing of distribution. So here we have x times r plus s. And that's equal to t. Notice here, this x and this x are common to both the rx and the sx, and I can pull them out. I can pull that x out front. Because if I were to distribute this, I'd end up with rx plus sx. So that's my factor portion, and now I want to divide both sides by r plus s. All of that goes to 1. All of this goes to 1. Divide both sides by that. And now I can see that x equals t over r plus s. And that's my answer.